Hi everyone, welcome to the X737 Air Manager Overhead Project. Wanted to give you an update. I've been a little delayed. My mom had a stroke. I've had her into the hospital. Been trying to take care of her in the last week, so I haven't gotten much done for the last 2 weeks. Did complete the final 2 panels for the overhead, the main panels. Bulk of what I've done is first the Nav Transfer Panel. I'll show you what I've come up with on my version. As you can see, this is a fairly simple panel. What it's used is, as you know, there's a left and a right. For example, a VHF navigation, there's left and right. IRS left and right. That's inertial reference system. FMC, which is the flight management computer, there's a left and a right. And the display sources can be changed too. So basically this is the way it works. Let's say the number 1 VHF nav was out. I could select this position here, and then both the captains and the first officers would be using the same nav. Normal, of course, is to have separate, the left on the left and the right on the right. The 1 on captains, 2 on first officers. Same thing with the IRS. There's 2 IRSs. They work independently, but if one was to fail, I can select left or right and put both systems on that and not lose anything. We lose redundancy, but we don't lose any cockpit displays. Same thing with the FMC. Should one fail, we can put both on one computer, or left or right, or leave it in normal where they're separate and redundant. Same thing with the control panels for the displays, and also the source for the displays. That can be all on 2, all on 1, depending on the position. So that's a fairly simple panel, but sometimes useful. Most of the time it's going to be operated with everything in the normal position in auto for source, and that's probably 99% of the time. Only when things break, go to your minimum equipment list or checklist, and they'll tell you how to use that. So anyway, that's number 1. That's the first panel that I took a look at in the last couple weeks. The second panel is the flight control panel, which actually was somewhat of a complicated panel. There's a lot of guarded switches and some temporary switches. It's a good number of lights to do, so I'll show you that one in my version. As you can see, there's a guarded flight control switches here, spoiler switches here, yaw damper control and light here, and there's some other lights I'll explain here. Then an alternate flap system, which can use the standby lights for the standby hydraulic system. As you may know, there's an A system hydraulics and there's a B system, and then there's a standby system. And the standby system basically runs only very important things, not the flight controls, because the flight controls can be operated off of manual reversion, basically, just like turning the power steering off on your car. But there are times when both of those could fail, and without some way to control the rudder, it would be curtains. If you were doing a takeoff and lost an engine and you didn't have any power to that rudder, you just wouldn't have enough force to keep the airplane going straight. So that's required in the standby rudder system. So the standby hydraulics also control flaps in a standby mode here. So let's look at how this works. First, let's look at the spoilers. They're fairly simple. These are really only used by maintenance, but they're guarded switches. There's an on and off position. I can see I left an off here off, but I'll fix that. But as you can see, you can flip that switch to off, and it just takes power away from the spoilers, the A system spoilers, into B system. The A is the inboard ground spoilers, or the inboard spoilers. B is the outboard spoilers. So you can, if you lose one of these systems, you still maintain 50% of your spoiler system, but not everything. It's not totally redundant. It's not that critical. Okay, we have a yaw damper switch. So normally you fly with it in the on position, the light's out. If you turn it off, the yaw damper light comes on. Okay, the standby hydraulic system, there's a low quantity light to tell you if the hydraulic system low quantity is at a critical low quantity level. There's a low pressure system for the standby hydraulic system, and there's a standby rudder on light. Now The standby hydraulic system is only turned on when you either put the alternate flap master to arm or you turn either the A or B to standby rudder. Those are the ways you can do it with the switch to turn on these. And these lights aren't armed normally. Now, the flight control switches, and I'll show you the B because there's a little problem the way this is programmed on X737. I've reported it to Benedict, and he'll be fixing it, I'm sure. But basically, you normally fly with the guard down and the B system on and the A system on. You can also turn it off, and if you turn it off, you can see the yaw damper disconnected there. And but this low pressure light should come on too, because this low pressure light tells you that that you have low pressure to the A side, in this case the B flight controls. Now we can put the switch to the standby rudder in this light. So this light should be, I believe this light should be off with the switch in off position. I think that's another minor error on the logic of this panel right now. When it's on, of course, it should come on if it loses pressure. If it's off, it loses pressure, and it should be on. And then if it's in standby rudder, something strange kind of happens. This becomes, instead of a low pressure light, it really is a standby rudder position valve indicator. Same thing with the A, except there's a small problem here. The lights, seems to have these the switch in an inverted way. So you have to move it up to get it to go down and down to go up. So there's this switch in the 737. You can check it over here too. It's the same way. Watch, I have to pull it up to make it go down and pull it down to make it go up. So that'll be solved too, I'm sure. That's just a minor glitch, but the guards are normally down on these switches. As I say, this is maintenance, so they're down. Normally this light is low quantity, this is low pressure, and those lights are only armed when the pump is operating. And then the standby rudder on tells you when that valve. Now that should tell you also when the valve position moves. That standby rudder is going to come on when you turn standby rudder to turn this to standby rudder. So that light should come on. Okay, now alternate flaps. There's an arm. You need to arm it. So this switch, even though you can move this switch up and down, it's not doing anything till you arm it. When you arm it and just momentarily go to down, that causes the leading edge devices to go out and they can't be retracted. The trailing edge flaps take quite a while to operate. You have to hold this down for quite a while and they move very slowly, but you can get the trailing edge devices down and back up. But the leading edge devices, which gives you a considerable speed restriction, cannot be retracted once they're extended, which means that once you extend those things on an approach, if you miss the approach and you have to go to an alternate, you're going to be flying at a reduced speed with those slats down. So it's something to think, slats extended, that's something to think about. Okay, one other set of lights here, and these are kind of warning lights associated with the flight control. First, field differential pressure. It basically tells you when the A system in the B system on the FEAR group, as I said, the feel system, the elevator, the aileron, and the rudder, FEAR, F-E-A-R. When those are in disagreement, the pressures are in disagreement, you get this light, because that's telling you there's some anomaly between the two systems that they're not getting equal pressure to those controls. Then you have a speed trim. The speed trim is a system that basically trims the airplane when you're flying in without the autopilot at low speeds. Sometimes, like right after takeoff, you'll see the elevator trim running forward even though you don't have the autopilot on, which kind of freaks you out at first. But that's normal. They just want to reduce the forces on that stick so that you can fly, so the airplane flies better, easier to fly. Then we have the Mach Trim, and that fail, and basically these lights tell you that the system has failed. The Mach Trim fail is a light to tell you when that system, which is designed at high speeds to make a correction to the elevator trim corresponding to stabilizer movement, again to improve flight handling characteristics at high Machs above 0.615 or something like that. And then we have an auto slat system, and this is the auto slat fail, and this comes on when if you get slow and the approach stall angle of attack, the slats, leading edge slats, will automatically deploy to give you additional stall margin. So that's another nice system to have. Now, an interesting thing about these three lights, sometimes when you do a master caution, master recall check, let me go back to that view if I can here. You go down here. When you go to, I'm going to have to move this over just a bit. When you hit the recall, sometimes when you hit the recall, these lights will come on. One of these three lights. And see, these three systems each have a left and a right, dual channel system. If only one of the channels, now obviously if both channels fail, you get the light on. But if you hit the master recall and while you're pushing it in, these lights come on, and then you can hit it again to reset them. But that tells you that one of the channels is out. You still have the capability with the remaining channel, and you need to write it up, but this just tells you that that one of the channels has failed, and that's when you hit the master caution recall and one of these lights come on. So that's pretty much it. The flight control panel is a little bit complicated, as I said, but and there are a few errors right now with X737 that require you to move the switch in the wrong direction on the flight control system. But other than that, not too complicated. Now I'll show you real quickly one last thing, and this is just an update on the overall panel that we're working on for the overhead. Now you can see we've pretty much completed all four major columns of the system. There's still the center section here, and there's the light across the bottom. I'll see if I can't show you that in another view. Let me get rid of this now. But that's basically the this section here down the center, you can see, and then the light panel across the bottom. And when that's done, the overhead will be pretty much complete except for the aft overhead, which has not been modeled in X737, although I understand from Benedict, a recent email, that that's coming along shortly, and that will be added. And when that's done, I'll go ahead and start working on that. I may do some of the graphics of the aft overhead panel before I can complete the graphics before I'm ready for the before he gets it done, and that would save me a lot of time, because probably 2/3 of the time is spent getting the graphics together to make the thing work, and the easy part really is writing the code to connect things up to the simulator. So anyway, that's it. Check back soon for another update. Thank you.